This is an explanation of a game called Kaos. This is for CS 102, fall 2009. And the idea for this game came from a Mindware website. So this is a two-person game, and the objective of the game is to get all of your 12 pieces on the board before your opponent does. And it's tricky because in certain moves, pieces can go back off the board and they revert back to the player that they came from. So let's say that gray goes first. So say gray takes a piece and places it here on the board, and then the pieces can be stacked. So then red goes and stacks on top there, and let's say gray then goes and stacks again. Now at this point, if red is going to go and stack on top of this, when there's a stack, so there can be at most 4, and when the 4th piece is placed, then the pieces need to be redistributed from the perspective of the user placing the piece. So when red places a piece here, then the pieces will be redistributed starting with the direction across from the player. So if red places here, then we're going to move the first red piece up off the board. If it were gray playing, then the first move would go the other direction, and then it proceeds in a clockwise direction. So here goes red. Red's going to place his 4th piece right here. So now that there's 4, the pieces need to be redistributed, and so the first move is away from red. It goes off there, and then we go clockwise. So the next piece goes here, next piece goes here, next piece goes here. So clockwise direction, but not counting the diagonals. Now, 2 of these pieces have been placed off the board, so these will get returned to their respective places, and then play continues at this point. There can be a chain effect of events. So let's say the board looks something like this, and let's say it's the turn to move for gray, and let's say that gray decides to place a piece right here. So gray places the piece, so these are stacked, the stack of 4. Now from the perspective of gray, the first move is away from gray, so this is going to go down is the first one, and then we proceed in a clockwise direction. So out there, and then up and to the right. And now we see that when we do this, that we're going to get another stack of 4. So now this again is the move for gray. Gray's been making the move, so all of the initial moves in the redistribution are away from gray. So the first one will be down, left, like so, and then we're done. And this one reverts back to red down here for continuing play. Consider what could be a more complex scenario of a chain of events that affect each other, of the redistributions. So let's say that gray is going to play, and gray is going to place a piece here on top of 1. So we have to keep track now that in position 1, the stack at position 1 on the board has to be redistributed. Okay, so there's position 1. So from the perspective of gray, that means the first piece is going to be to move down here like that. So now also position 4, square 4, has to be redistributed. So first we need to finish 1, and after that we'll go to 4. And so we do the redistribution, and need to make a little adjustment here since I'm doing this in Microsoft Word to make sure that these things all line up. So we finished with 1, now we have to go and do 4. So again, from the perspective of gray, that made the move. So I'll take, this one goes that way. I'm going clockwise off the board, up. So we did 4, and we also, 2 also needed to be added to the list, square 2, because that's a coalition of 4. And now we've made a group of 4 also at square 5. And so that has to be added to the list of ones that need to be handled. And again, since I'm doing this in Microsoft Word, let me fix this so that it looks correct. So now I need to take square number 2, which was the next one in line to be handled. So first thing I do is I go to move this down, but now here we have a problem. If I move this down, that would make a stack of 5 rather than a stack of 4. The maximum is 4. So in this situation, what happens is that piece just immediately goes off the board and doesn't get stacked at all. So that would be the first move. Second move would be in that direction, like so. And lastly, now we have at square 5, we have to do the redistribution for square 5. So what I recommend for this is that you make a list of just make it an array of integers of the squares that have stacks of 4 that need to be handled. And the 0th position, that is the first position of the array, is always the position that where we need to do something. That is that we need to do the redistribution. Here's my suggestion on how to organize this redistribution. Have an array. In this case, I have an array called squares to redistribute, and that's just an array of integers where when I have a square that needs to be redistributed, I just enter it into this array. So again, let's say that gray is going to move, the scenario we saw a moment ago, and when gray moves onto this spot right there, then I see that now I have 4 in a stack, and that is at square number 1. So I'm going to put number 1 there. And I'm always going to handle the one that's at the bottom of this table. So square number 1 needs to be handled and redistributed from the perspective of gray. So I'm going to take the gray piece and start doing the redistribution. As soon as I do this, then I create another stack of 4, and that's in position 4. So then I make an entry here that one needs to be handled next. And then I continue from the perspective of gray doing my redistribution. And now here I see that I've also created a stack of 4, and so what I have to do here is I also have to take and put the number 2 on my list to say that I need to handle that as well. Now that I've finished doing the redistribution for number 1, then what I'm going to do is I'm going to cross this one off of the list and move the others up. So that's going to be a for loop that goes through this array and takes each element and just copies it over onto the previous element. So the 4 gets copied onto the 1, the 2 gets copied onto the 4, and then this gets deleted. So then we can continue. What's the next one on the list? It's always going to be this one up here. So the next one to be processed is at square 4, which is the second one that got created. So I'm going to take the top element of the list, again from the perspective of gray because it was gray's move. That goes that way, this way, up, and now I'm creating another coalition of another stack of 4. So I have to add that one to the list, which is at square 5. So I add that to the list. And then what's the next one? So let me see. So now I've finished with 4. So then this has to be deleted off the list. So I copy these down, 5, and leave that blank. And again, now I need to process this one next. So I start with 2, and this would now make a stack of 5. So as we've seen, that just goes straight off the board. And we continue, and then I copy this down. So 5, that gets deleted, and the last one to be handled is the stack for 5. And as soon as the total number to be handled disappears, then we're done. So I actually encourage you not only to have an array for the squares to redistribute, but to have a variable that says how many are there on the list as well, and update that as you go.